So, when you think about the spacecraft that's traveled the farthest from Earth, what comes to mind? You're probably picturing some crazy, hyper-advanced technology, right? Something straight out of a movie. But the real story? The actual code that has kept humanity's greatest journey alive for almost 50 years? Well, it's a lot weirder and, frankly, a lot cooler than you might think.
Let's wind the clock back to 1977. NASA launches the Voyager probes. And on board each one is a golden record. It's basically a message in a bottle, hurled into the cosmic ocean. This quote from President Jimmy Carter just nails the sheer ambition of it all. Sending a tiny piece of who we are out into the great, silent unknown, hoping someone, someday, might find it.
And just how far have these probes gone? We're talking about 40 billion miles from Earth. That's a 4 with 10 zeros after it. Just try to wrap your head around that distance for a second. It's just staggering. What's really mind-blowing, though, is how long they've lasted. Since 1977, these machines have been working, non-stop. In 1990, Voyager 1 turned its camera around and took that famous pale blue dot photo, a picture of our entire planet, just a single tiny pixel in a sunbeam. They are, to this day, the longest operating computer systems in history.
So, you gotta ask, right? To work for decades, across billions of miles in the freezing, hostile vacuum of interstellar space, what kind of next-level genius technology is keeping these things alive?
The answer is not what you'd expect at all. The core software controlling the Voyager probes was written in a programming language that was already considered ancient back in 1977, a language born in the 1950s. It's called Fortran. Yeah, you heard me right. So how on earth did that happen?
To understand Fortran, first you have to understand its creator, a man named John Backus, who was pretty much the definition of an accidental genius.
Backus's path was, let's call it unconventional. He got booted from college for not showing up to class. He bounced around the army. He even tried medical school, but dropped out after about 9 months. But not before he tried to design a better metal plate for his own skull after an operation. I mean, that tells you something about how his mind worked. It was only when he got into amateur radio that he discovered he had a real knack for math, which eventually led him to a master's degree.
And his career started in pretty much the same way. In 1950, he's walking down Madison Avenue in New York, sees one of IBM's giant computers in his showroom window, walks in, and just asks for a job. After a quick chat, they hired him right there on the spot.
Okay, so you have to understand, the world of computing that Backus just walked into was, well, it was facing a crisis. A huge, expensive, and deeply frustrating crisis.
In the early 50s, programming was an absolute nightmare. For 3 years, Backus's job was programming a machine called the SSEC. This meant finding and fixing mistakes by hand on a computer that crashed every few minutes. It was agonizingly slow, brutally difficult, and incredibly expensive. And here's the core of the problem. On one side, you have the machine. It only understands these long, meaningless strings of ones and zeros. On the other side, you have a scientist or an engineer who thinks in the clean, elegant language of math. The gap between them was enormous, and it was costing a fortune to bridge. The situation got so bad that IBM's own customers started to complain. They were basically saying, look, these amazing million-dollar computers you sold us, they're basically just expensive paperweights if it takes us weeks to write and debug one simple program.
Backus, completely fed up with how inefficient everything was, came up with a radical idea. He thought, what if, instead of forcing humans to speak the computer's language, we could just teach the computer to understand ours?
And that idea became Fortran. The name says it all, really. Formula Translating System. It was a language designed from the ground up to let a scientist write code that looked almost exactly like the mathematical formulas they already used every day.
And the team Backus put together to build it was just as unconventional as he was. I mean, this list reads like the cast of a heist movie. He gathered programmers, sure, but also mathematicians, a chess expert, a crystallographer. He specifically wanted brilliant people who, and this is the key, weren't even sure that what they were trying to do was possible.
And man, it was a massive undertaking. Backus himself said that what he thought would be a 6-month project ended up taking 3 full years. They spent 2 of those years just building the compiler, the incredibly complex program that would do the actual translating from Fortran into machine code.
So, was it worth it? Oh yeah. The result was breathtaking. Fortran cut down the number of lines of code a programmer had to write by a factor of 20. Think about that for a second.
A job that used to take 20 weeks of painful, error-prone work could now be done in 1. It wasn't just an improvement, it was a complete revolution.
And that revolution, born out of frustration in the 1950s, is ultimately what put Fortran on a tiny spaceship, pointed it at Jupiter and Saturn, and sent it on its way to the stars.
Because it was so good at math and so efficient, Fortran pretty much instantly became the mother tongue for all high-performance scientific computing. It was the language you used to solve the biggest, hardest problems in the world.
And its influence was just immense. For decades, it was the secret engine behind breakthroughs in almost every scientific field imaginable. Astronomy, climate models, physics, fluid dynamics. If you were doing serious number crunching, you were almost certainly doing it in Fortran.
Okay, so you're probably thinking, fine, but that was then. Surely it's just a museum piece now, right? Wrong. The TOB index tracks how popular programming languages are. As of late 2023, Fortran was ranked number 11 in the entire world, still ahead of thousands of other languages that were created decades later.
And get this, as if inventing Fortran wasn't enough for one lifetime, Backus also created something called the Backus Naur Form, or BNF. It's basically a universal grammar for describing programming languages, and it's the foundation for nearly every major language we use today. Python, Java, C++, they all owe a debt to it.
And all of this leads to this moment of just beautiful poetic symmetry. Because in 1977, the very same year that the Voyager probes launched into space carrying his creation, John Backus was awarded the Turing Award, which is basically the Nobel Prize for computer science. And that really leaves you with this one final thought. In our world, a world that is obsessed with the new, with constant updates and things designed to be replaced, how is it that an idea from the 1950s, built by an accidental genius in this team of misfits, is still out there, carrying our message to the stars? Maybe it just proves that the most powerful ideas aren't always the newest ones, but the ones that solve a really hard problem really, really well.